All right, you're going to want to hear this. Meta AI just dropped something that might completely change the game for how artificial intelligence actually, well, reasons. We're going to break down what it is, exactly how it works, and why this is such a massive, massive leap forward.
But to really wrap your head around this, let's start with something that honestly seemed pretty much impossible until now, an achievement that just begs for an explanation.
Take a look at this number, 99.9%. You know, on its own, it's just a number. But with a little context, it represents a truly staggering breakthrough in how AI can solve problems. So that 99.9%, that was the score an open source AI got on the AIME 2025 exam. And look, this is not your average math test. The AIME is designed to find the absolute sharpest young mathematicians out there. We're talking the future International Math Olympiad geniuses. This test is literally built to separate the brilliant from the truly elite. So you have to ask, right? How in the world did an AI get this good at reasoning through problems that are designed to stump some of the brightest human minds on the planet? Well, that's exactly what we're about to unpack. To really appreciate just how big a deal this is, we first have to look at the old way of doing things, the brute force method that AI has been leaning on for years. It's a technique called parallel thinking, and the idea is pretty simple, really. You ask the AI to come up with dozens, maybe even hundreds of different solutions to the same problem. Then, you just count them up and see which final answer appears the most. It's kind of like a majority vote deciding what's correct.
Yeah, but there's a huge problem with this method. It hits a hard wall. You get to a point where throwing more attempts at it doesn't really help, and sometimes bad ideas can actually pollute the whole thing and make the accuracy go down. Plus, it's insanely expensive. It just burns through computational resources, or tokens as they're called. And this little chart here, it lays it all out perfectly. We're moving away from a brute force, expensive system that hits a ceiling to something that's just smarter. It's efficient, and it's all based on confidence.
And this new method is called Deep Comp, which is short for Deep Think with Confidence. And that word right there, confidence, that is the absolute key to this whole revolution in AI reasoning. The core idea is actually pretty elegant. Instead of just treating every solution path as equal, Deep Comp teaches the AI to listen to its own internal confidence signals. It basically learns to check how sure it is about each step it's taking. You know, just like when you're doing a tough math problem and you pause because a certain calculation feels a little off. So how does it do that? How does it measure its own confidence? Well, it's this really clever four-step check. First, there's token stability, which is kind of like a spell check for logic, making sure the individual building blocks are solid. Then, it scans group sections to look at bigger chunks of the reasoning and smooth out little mistakes. Next, it analyzes the final answer, because that's where mistakes are most critical. And finally, it actively spots the weakest links by finding the single most uncertain part of the whole thought process. Altogether, these create a detailed health report for every single solution.
Okay, so the theory sounds great, right? But does it actually work in the real world? Well, the proof is in the numbers, and honestly, they are absolutely jaw-dropping.
Just look at this. On that ridiculously hard AIME exam, the standard model already scored a super impressive 91.8%. The old brute force method pushed it up to 97%. But with Deep Comp, it rocketed all the way to a near-perfect 99.9%. That is a monumental leap when you're already pushing the limits of what's possible. But here's where it gets really crazy. It didn't just get smarter, it got way, way more efficient. While it was getting that near-perfect score, it used almost 85% fewer tokens than the old brute force way. I mean, think about that. Way better results for a tiny fraction of the cost. And this wasn't some one-off fluke either. The results were consistent across a bunch of different models. It didn't matter if it was a smaller model like DeepSeek 8B or a huge one like Kuan 332B, they all saw these massive jumps in accuracy while at the same time slashing their computational cost. This technique just flat out works. So a technical breakthrough is one thing, but what makes this really transformative is who actually gets to use it. And that brings us to the final and maybe most important part of this story: power to the people. I mean, listen to this quote from the researchers themselves. You don't need a supercomputer or a team of PhDs to retrain a massive model. You can get this revolutionary reasoning tech working with about 50 lines of code. It's literally designed to be plug and play.
And this is why making both the technique and that record-setting model open source is such a huge deal. It means anyone can look under the hood and see how it works, which speeds up innovation for everybody. But most importantly, it democratizes access to this kind of incredibly powerful AI.
And really, that's the bottom line here. This isn't some secret tool locked away in a corporate vault. This new, incredibly powerful way for AI to reason with confidence, it's now out there for developers, researchers, and creators all over the world to use. So, I'll leave you with this final thought. For so long, the big hurdle for AI has been its ability to reason reliably. Now that an AI can solve problems with this incredible level of self-awareness and confidence, the question isn't if it can reason anymore. The question is, what huge, complex, real-world challenge should we point it at next?